In this video, we will look at some examples in probability. First example, if a single coin is tossed, find the probability that it will land heads up. In the long run, we will see that there is no reason a fair coin will land heads up more frequently than tails up. So we assume they are equally likely. The sample space is S equals the set of H and T, and the event whose probability we seek is E equals H, heads. Because only one of the two outcomes is a head, the probability of heads is 1/2. Another example, if a red solo cup is tossed, find the probability that it will land on its mouth. To figure this out, we must do an experiment. Throw a red solo cup 50 times. When the book's authors performed this experiment, they found the cup landed on its side 44 times, on its mouth 5 times, and on its bottom once. So the probability that it will land on top or on its mouth is 5/50 or 1/10. Note, if you perform the experiment yourself, you may get very different results. In example 1, we used our knowledge of coins to observe that flipping heads is as likely as flipping tails. We obtained the probability theoretically. Theoretical probability formula. If all outcomes in a sample space S are equally likely, and E is an event in that sample space, then the theoretical probability of event E is given by the formula P of E equals the number of favorable outcomes divided by the total number of outcomes, which is N of E, the number of favorable outcomes, divided by N of S, the total number of outcomes in the sample space. In the second example, the outcomes were not intuitively clear. An experiment was performed to determine how the cup would fall, and there is no guarantee that the experiment would have the same results if repeated. I repeated the experiment, though my cup was blue and Hy-Vee brand, and I only flipped it 25 times. The cup landed on its side 19 times and on its mouth 6 times. So that's 76% side and 24% mouth. The empirical probability formula. If E is an event that may happen when an experiment is performed, then an empirical probability of event E is given by the following formula. P of E, the probability of E, is equal to the number of times E occurred divided by the number of times the experiment happened. For example, Kathy wants to have exactly 2 daughters. Assuming that boy and girl babies are equally likely, find her probability of success if A, she has a total of 2 children. We can use a tree diagram to determine the probability. Here this blue determines the gender of the first child, the red determines the gender of the second child. So we follow the blue up to get G, and up again to get G, and then we have GG. But everything else includes at least 1 boy and only 1 girl. The probability of success is 1/4 or 25%, since only 1 of 4 equally likely possibilities is successful. If instead she has a total of 3 children, we set up our tree diagram, and we see that there are, in fact, 3 possibilities where she has 2 girls. There are 8 ways to have 3 children. So N of S, the number in the sample space, is 8. And 3 of those ways have exactly 2 girls. N of E equals 3. Therefore, P of E is 3/8 or 0.375. One more example. According to US Census figures, on July 14, 2018, there were an estimated 162.4 million males and 166.9 million females. If a person were selected at random from the population that day, what is the probability that the person would be a male? Given the experimental data in the question, this is an empirical probability. The probability that a person is male is the number of males divided by the total population. That's 162.4 million divided by 162.4 million plus 166.9 million. And that's about 0.493 or 49.3%.